Okay, so this was the first one on that horizontal sheet, okay, that we wanted to go over here. So we have this amusement park ride. We know it has a radius of 2.8 meters. Okay, so they gave us R. The time for one revolution is 0.98 seconds. What did they give us there? Period. Yeah, okay, which is big T. Okay, 0.98 seconds. Okay, what's the speed of the rider? All right, so this one's a pretty basic one in that it doesn't even use the centripetal force formula. Okay, I'm looking for V. I have the radius and the period. Okay, so I'm really just using this one here. Okay, just thought I'd throw you a slow one to see if you get it. Okay, 2 times pi times 2.8 meters. Okay, divided by 0.98 seconds, and that should give us our 18 meters per second for the speed of that ride. Okay, questions on that one? Okay, is it possible that you could get an easy one like that on your unit exam? In the multiple choice, absolutely. Yeah. Okay, I'll put a few more up here and give you some more time to work on those. Okay, let's have a look at number 5 here from the first sheet. All right, so for number 5, okay, we know we have an electron, so we know its mass is 9.11 times 10 to the minus 31 kilograms. Okay, we know that it's moving in a circle with a radius of 2.00 times 10 to the minus 2 meters. And if the force acting on it, okay, is 4.6 times 10 to the minus 14 newtons, what's the speed? So they basically told us, here's the centripetal force, 4.60 times 10 to the minus 14 newtons, okay, because that's the force making it go in a circle. Okay, we're just looking for V. Okay, so we've got Fc equals mv squared over r. We're looking for v, so we're going to multiply both sides by r, divide both sides by m, and then square root to get v. So v will be the square root of 2.0 times 10 to the minus 2 times 4.6 times 10 to the minus 14 divided by 9.11 times 10 to the minus 31. All right, so you gotta be careful here with your brackets. Okay, so we're gonna have brackets, 2.0, okay, e negative 2, close the brackets, okay, 4.6, e negative 14, close those brackets, close the top. Okay, divide by the bottom, 9.11, e negative 31, close that bracket off. Okay, then we got to square root that. Okay, so that ends up being 3.2 times 10 to the 7 meters per second. Okay, well, we have 3 significant, sorry, 3.18 times 10 to the 7 meters per second. Okay, makes sense that an electron would go really fast, okay, as they are very, very small. Okay, everyone okay with that one? All right, how many people are done number 8? Okay, do we need to go over number 8? Okay. All right, now, as I was saying before, number 8's a bit of a generation gap question, okay, in that we're talking about the old black vinyl records, okay? So they spin on a turntable. I'm sure you've seen that somewhere, okay, along the way. But the big ones used to spin at 33.33333 repeating, okay, revolutions per minute. So if I give you how many revolutions it goes around in a certain time interval, am I giving you the period or the frequency? I'm giving you the frequency. If I gave you the period, I'd tell you how long it took it to go around one time. I'm telling you how many times it goes around in 1 minute. That's frequency. Okay? So I'm telling you that the frequency is 33.3 repeating, okay, revolutions per minute. Do we usually use minutes as a time? What do I want it in? Probably in seconds. What do I divide that by to get it in seconds? Divide by 60. It'll be in revolutions per second, okay? But that makes sense. If it does 33 1/3 revolutions per minute, does it get around once in a second? I don't think so. If it did, it would go around at 60 hertz. Okay, so it's not doing that. Okay, so what we're going to do here is we're going to go 33 point, and I'm just going to put a bunch of 3's in there. Okay, okay, that's how many times it goes around in 1 second. A little more than 1/2. Okay, that kind of makes sense. Okay, given the frequency we had. All right, so now I've got my frequency in hertz. Okay, the diameter of the record is 30 centimeters. Do we ever use diameter for anything? This has just got all kinds of tricks in it. That's why I picked it. Okay, got all kinds of tricks. I only want the radius. 0.15 meters. Heck, don't want centimeters either. Okay, now that I've got those things, okay, I want to calculate the speed and the acceleration, okay, of that record. So V equals 2 pi r over t. Now, one of two ways you can do this. Go 1 over this number to get your period, or just know that this is the same thing. Since f is 1 over t, I could simply multiply by the frequency and get my speed. So 2 times pi times 0.15 meters times 0.5 repeating, okay, and that will give me the speed of that record. So 2 times pi times 0.15 times that number there. Okay, 0.524 meters per second would be the speed. Okay, so a few contextual tricks in that question. Okay, the next part, it wants to know the acceleration. Well, centripetal acceleration is v squared, which I just calculated, or v, which I just calculated, over r. So I take that number I just calculated, 0.524, and I square it, and I divide by 0.15 meters, sorry. Right, and I got an acceleration there of 1.83 meters per second squared. And if I really wanted to be specific, so that's supposed to be squared, I could say this. And the reason I might include that is that they never did say I was looking for the centripetal acceleration. If they said centripetal acceleration, then towards the center is implied. Because they only asked for the acceleration, I should probably say it's towards the center. All kinds of really mean, nitpicky details in that question. Okay, but it makes us think. That's why I picked it. All right, I'm going to give you a few more minutes here to get done 12 and maybe the first one on the vertical sheet here. All right, let's have a look at number 12 here, the banked curve question from that first sheet. All right, so they tell us it's a 745 meter curve. If they put it that way, they say the curve is this many meters, what are they giving you? The radius. They're giving you the radius. No question is ever going to say the circumference of the curve is this much. And if they did, they would actually literally say it is the circumference. Okay, if they just when they're describing the curve in meters, they are saying that's the radius. Okay, so r equals 745 meters. Okay, and it is to be banked for cars traveling at 90 meters per second. Okay, so we know what v is as well. We're looking for the angle of bank for extremely icy conditions, which basically means the curve would be frictionless. Yeah, if it says very icy, it means it's frictionless. Okay, so that said, we know then that the formula for banked curves is that the tan of theta is equal to v squared over r times g. As soon as you see a banked curve question, that's the formula you go to. Okay. All right, so I'm looking for theta. If I want to get theta by itself, I've got to get rid of tan. which means I take the inverse tan of the other side. Okay, so theta will be tan to the minus 1 of v squared over r times g. Okay, so that's going to be tan to the minus 1 of 90 squared, that was the speed they gave us, divided by 745 meters times 9.81. All right, and when we plug that in, that is banked crazy. That is more than halfway to vertical. Ever so slightly more than halfway to vertical, but still more than halfway to vertical. Okay, it would be difficult to stand on that. Okay, that is very, very tilted. Okay, everybody all right with that idea? Okay, I'm going to give you a few more minutes to get into the vertical ones here. We'll go over a couple of those in a few minutes. All right, so for question number 1 here, you're riding your bike on a track that makes a vertical circular loop. So like what we watched Damian Walters run through, except on a bike. Okay, the diameter of the loop is 10 meters. What's the trick here?
It's half of the diameter.
Right, I only want the radius, not the diameter. Okay, so radius is going to be 5.0 meters. Okay, how fast would you have to travel, so we're looking for v, in order to stay in the loop? What particular speed are they asking me for here? It has a special name. What do we call the speed you have to attain to just stay in the loop? Starts with M. The minimum speed. You only have a minimum speed in this situation. Okay? When you're going over, or under the top rather, of the vertical loop, or gravity could pull you off if you don't go fast enough. Okay? So this is the only place that kind of tells us, okay, that we're dealing with this position. Okay? So it's context that usually tells us we're dealing with that position. And because we're going just fast enough to stay in the loop, we don't push on the track. Thus, Fc, which equals forces in minus forces out, okay, has A, no forces out, and only one force in. So we got mv squared over r equals m times g. Oh my gosh, you wouldn't believe it again. Okay, so got to multiply both sides by r, okay, divide both sides by m, square roots, okay, so we got the square root of 9.81 times the radius, which was 5, okay, that's going to give us a minimum speed of 7 meters per second. Okay, questions on that one? All right, so the trick with those minimum speed questions is the wording. If they say something like going just fast enough, okay, or something like that, okay, they may not even imply or even directly say that, hey, it's the top of the loop. But if they say just fast enough, there's only one place where there's a just fast enough, and it's the top on the inside. Okay. All right, for number 3. Okay, so a student has a weight of 655 newtons. What did they give me?
FG.
They gave me Fg. Okay, while riding a roller coaster, this same student has an apparent weight of 1,950 newtons. Well, apparent weight is normal force. Okay, at the bottom of a dip, all right, that's useful information, although that's really the only place they could be that much heavier. Okay, so we've got normal force and gravity. Okay, and the radius is 18 meters. All right, so I'm supposed to find the speed of the roller coaster. Am I going to need the mass for that? Probably. Can I get it? How do I get it? France, how do I get it?
N times G.
Right, Fg equals m times g. So I'm just going to take that 655 that I was given, divided by 9.81, okay, and I'll have the mass. So 655 divided by 9.81, okay, gives me 66.77 kilograms. Okay, that's going to be helpful. Now I'm going to go back to this. For a vertical circle, forces in minus forces out gets me the net or centripetal force. Okay, in this case, okay, that is going to be normal force minus the force of gravity equals mv squared over r. Okay, so I'm trying to find V, so I'm going to bracket this subtraction operation. I'm going to multiply both sides by r, and then I'm going to divide by m, because I spent some time getting that, and I should use it, and then I am going to square root. I don't actually have to put in m times g or anything, because they told me what fg and fn were. Okay, so that was convenient. It saves me a little bit of time. Okay, so fc equals, okay, 1,950 newtons minus 655 newtons times, that has to be in brackets, times the radius, which was 18 meters, and then divided by 66.77. I'll actually use all the decimals when I do that calculation. Okay, so 1,950 minus 655 times 18, okay, divided by that number there, and then I'll square root that. Okay, 18.7 meters per second, okay, would be my necessary speed. I don't know why I got 18.7. Did I misread? Did I mess something up? Oh, I probably rounded this off. I did it myself. Okay, everyone all right with that? Okay, I'm going to give you just a little bit more time to finish up 4 and 10. If you're done 4 and 10, you could check and make sure your lab is ready for tomorrow and on your phone. Do that kind of good stuff. All right, guys, let's have a look at number 4 here. So we have this vertical circle. Okay, the diameter of the ride is 5.8 meters. So once again, that silly trick where they gave us the diameter, okay, and we only want the radius, so we're looking at 2.9 meters, okay, for our radius, and we know the mass, 75 kilograms, okay, and we want them to remain against the wall when they are in the top position, which would be like they're on the inside at the top of a vertical circle. Would you agree? Just like that Kuza video we watched where the guy would actually just be laying on the inside of that circle, and when he went around, he didn't fall off. Okay? Exactly the same situation. All right, so we are looking for the minimum speed for that loop. Okay, so this situation here. Okay, I always draw a car because I can't draw anything else. Right? But in this case, since he's going just fast enough to stay there, there's only gravity present. That's always the case when we're talking about the minimum speed. Okay, so we've got mv squared over r equals mg, and then, oh my gosh, I can't believe it happened again. Okay, g times r, 9.81 times 2.9. Okay, it's going to give us that 5.33 meters per second. Okay. All right, how many people are done 10? Okay, I'm going to give you like 2 more minutes to do number 10, and then we'll go over number 10. Okay. I'm serious about that liquid sunshine, isn't it? Should we use our physics knowledge to build an arc? We're probably okay for a while. You won't have to shower tonight.
Yeah.
Take a bar of soap with you. Find out how to do it.
Yeah.
Oh shoot, I was recording that. That's gonna sound really stupid. Okay guys, so let's have a look at this one here. So they're telling us the radius and the mass right off the bat. So we know the mass is 1,050 kilograms, and they tell us that the radius of the loop is 10 meters. Okay, and they tell us the speed. All right, so first one is they want to know the force of the track pushing up on the roller coaster when the car is at the bottom of the loop. Okay, so if we're at the bottom of the loop, okay, the normal force is up. That's the force of the track. Okay, and then Fg here. Okay, so we're going to go Fc equals equals m times g. Sorry, that's backwards. Hang on. Is going to be normal force acting in minus the force of gravity acting out, and we're trying to solve for normal force. So all we do in this situation is go Fc plus Fg equals Fn. Okay, so we'll have our mv squared over r, okay, plus m times g. All right, so when we do that, okay, we're going to have 1,050 times 35 squared. Whoops. 1,050. Oh, come on, just do what I say. 1,050 times 35 squared divided by 10. Okay, so there is our centripetal force. Okay, 128,625. Plus our force of gravity, which is just m times g, so that's going to be 1050, okay, times 9.81, okay, so that's 10,300.5. Okay, so now that we know those numbers, we just add them together. Okay, that should get us our 1.4, okay, times 10 to the 5 newtons. Okay, everybody all right with that one so far? Yes? Okay. Now, what's the force of the track pushing up on the roller coaster when the car is at the top of the loop? Okay. Now, I'm assuming this one is going under the top. Was I right in that assumption? I think so. Okay. So if we're going under the top, okay, we're 35 meters per second is definitely faster than the minimum speed. Okay. That's definitely faster than we have to go to stay in this loop. So in that case, both of those forces are acting in. Okay? So Fc equals Fn plus Fg. There are no forces out, they're both in. Okay? And so now I have to subtract Fg over to this side, so I'll have Fc minus Fg equals Fn. All right, so when I'm doing that one, I just take those same numbers I had a minute ago, okay, the 128 here, okay, so that one, and I subtract that one. Okay, that should be our 1.2 times 10 to the 5 newtons. I believe that's what it said it was. Yep. Okay, everybody all right with that? So all this is doing is just checking, can you do forces in minus forces out? Because we already know that's the whole reason I wrote these numbers down here. I'm going to use those same numbers on basically every question, okay, for the rest of this thing. Okay? So what's the actual weight of a 50 kilogram passenger? So 50 times 9.81 would be your actual weight. Okay, so that's 4.9 times 10 to the 2. Okay, what is the apparent weight of a 50 kilogram passenger? And they go at the bottom of the loop. Okay, so all I do instead here, guys, is I substitute in 50 instead of 1,050. Okay, so basically this is a whole roller coaster with one person in it. And now we're talking about that one person, that 50 kilogram person. okay, as they go around. So all that changes here is I put in 50 for the mass for C, D, and E the rest of the way along. Okay, everybody all right with that? So it's just forces in minus forces out, okay, and we can quickly look at what that's going to equal. So, so D, bottom of the loop. Okay, so we'll have, yeah, Chase. Okay. So bottom of the loop, we're going to have F in minus F out. Sorry guys, I gotta write it down here. Okay, so we're looking for this, so we're going to take our FC and add our FG for that one. Okay, so that's going to be 50 times 35 squared, okay, divided by 10, okay, and then we're going to add that to 490.5. Okay, so there we get our 6.6 times 10 to the 3 newtons. And when we're at the top of the loop, okay, so on that one we are looking at, well, they didn't say whether that's top or bottom, or sorry, in or out, inside or outside. Okay, that's poorly worded. Okay, so we're going to say for that one, I'm going to say it's going over the top, and I could be wrong about that. Let's just say that's what we mean. Okay, so we're going to have FG, sorry, forces in minus forces out. Okay, and so we're going to add that over. So we're going to have 490.5 minus our centripetal force, which is that one. Oh no, we can't have that because that'll be negative. Okay, so it must have been on the inside then when we added them. Yeah. Sorry guys, I didn't realize how poorly worded those were. I'm going to reword those for the future here. It's terribly worded. Okay, quiz tomorrow. It's going to set the post in 5 minutes. Okay, so make sure you have a look at it. It's 2 vertical circular motion questions with a solutions video. Make sure your lab report is ready for 8:30 a.m. Okay, submitted on Google Classroom by then. Okay, and then tomorrow we're doing another lab. Same idea, except we changed the centripetal force this time. So we put a different mass on the bottom and do the same thing we did last time, except with a constant radius. And then Wednesday, we're doing the circular motion assignment. Thursday, we start gravitation, which is the last third of the unit. Okay, gravitation, satellites, gravitational field strength, done. Okay, so there's not much left. That's why your unit exam date is set for May 22nd. Okay, so maybe start having a look at things, okay, you know, a little bit each night in preparation for that over the next 2 weeks. Okay, that's it for today, guys.